Hello guys, welcome back in today's session. I am Professor Fayyaz Kawadi from Department of Mechanical Engineering with continuation with unit number 2 helical gear. In today's session we are going to discuss the force analysis of helical gears. I explained this figure before starting the analysis part. In this figure you can see the isometric view of helical gear, in which in this direction you can see the front view of helical gear, and from this direction or your right hand side you can see the side view of helical gear. Here the dotted line shows the pitch circle diameter of helical gear. In front view you can see the pitch circle diameter of helical gear in dotted view, and that is in XY plane. And in side view you can see the width of helical gear. Here for analysis purpose, point C is considered on the gear tooth profile. Point C is considered on gear tooth profile. At the same time, that point C is on pitch circle diameter. The location of point C is on the gear tooth profile. At the same time, if you see from the front view, that C point you can see on the pitch circle diameter. If you see in front view, you can see that C point like this. The C point is on pitch circle diameter. Okay. Now you can see here the F force which is acting on point C. On point C, that is the resultant force. A resultant force of force Ft, Fr and Fa. What are these forces? Ft, Fr and Fa, that we'll see in next slide. Before starting the next slide, discussing the next slide, first I would like to explain what is phi t and what is phi n and alpha, these three angles. Okay, now the phi t is pressure angle. Phi, we have used that pressure angle phi for pressure angle, but that pressure angle, as in case of helical gear, there are two different planes. One is a transverse plane and second one is a normal plane. As we discussed in previous session, transverse plane is a plane of rotation, and that plane of rotation is XY plane. Here XY plane. So if XY plane of rotation, and you can see that plane is perpendicular to the front view. Perpendicular to the front view. Okay, so the pressure angle in the transverse plane, is phi t. Phi t. Plane pressure angle in transverse plane is phi t, and that phi t pressure angle you can see in front view. In front view, that means that phi t is in the plane perpendicular to your eyes, and in this cube the triangle EDC, clearly understand that figure for finding the different forces. Phi t is in the plane which is perpendicular to your eyes, and that phi t is in the triangle EDC, that is a front face of this cube, okay, EDC. In that triangle you can observe pressure angle in transverse plane, and this transverse plane is parallel to plane of rotation. Okay, now phi n, pressure angle in normal plane, and this normal plane is perpendicular to this teeth. These are the teeth which are making angle alpha helix with the axis of rotation. As we know, all of the helix angle is angle made by teeth to the axis of rotation. Okay, so phi n is pressure angle in normal plane. This normal plane is perpendicular to the teeth, of helical gear. So this normal plane you can see in triangle ABC. This triangle is not perpendicular, is not parallel to front face also, and not parallel to back face also of this cube. Okay, this is inclined plane in this cube, inclined plane. Okay, and this inclination is nothing but pressure angle in normal plane and pressure angle to the plane perpendicular to the teeth on helical gear, perpendicular to teeth. So this triangle ABC is inclined to this cube or perpendicular to the teeth of helical gear. Okay, so understand this triangle clearly, ABC. Okay, and now the third angle is alpha. Alpha is the helix angle or angle made by teeth to the axis of rotation. So from triangle BDC you can find out angle alpha, and that plane BDC is on the bottom surface of this cube. Bottom surface is BDCI. This is the bottom surface of the cube, and this triangle lie on this bottom surface of the cube. Okay, so triangle BDC, in that triangle you can find the angle alpha. Okay, and this plane BDC is perpendicular if you see from top view. If you see, this is the top view and you are the observer here, and from top you are observing that gear, and from top you are observing that cube. At that time that triangle BDC is perpendicular to your eyes, and angle BCD is making alpha. Clear on this figure? Now see the different forces which are acting on point C. Now the first force is the resultant force. A resultant force acting on the helical gear tooth. Force which is acting on the helical gear tooth, that force is denoted by F here. From point A to point C, that point A is on top surface of this tube and that C is bottom surface of that cube. Okay, so from top to bottom, that is the resultant force. That is the resultant force and denoted by capital F. Okay, these resultant force can be resolved into three components. One force is tangential force, Ft, that is denoted by F suffix T, tangential force, which is acting on point C. Okay. Second one is a radial force, vertical force, Fr, that is denoted by Fr, F suffix R, a radial force. And third one is a axial force, F, capital F suffix A, axial force, towards the axis. These three forces acting on point C, and these are the component of a resultant force F, these three forces. And if you plot on a cube, you can see these three forces are mutually perpendicular to each other. Okay, now what is tangential force? The tangential force is a useful component of a resultant force F, and it is responsible for the transmission of torque. It is responsible for the transmission of torque or power. Okay, so here that is Ft, tangential force. It is the component of a resultant force F, and it tries to rotate the gear. Ft try to rotate the gear in clockwise direction. If direction of Ft is from left to right, so it will rotate the gear in clockwise direction, Ft. Okay, and it is always tangent to the pitch circle at pitch point. This Ft is tangential force at point C. Okay, so Ft is tangent to pitch circle diameter at pitch point. So it is given by, you know, the formula for torque as you learn in mechanics. Torque is equal to force into perpendicular distance. Torque is equal to force into perpendicular distance. So force, that is nothing but Ft, tangential force, is equal to torque divided by distance, perpendicular distance. So Ft is equal to torque divided by R, and that R is nothing but pitch circle radius, because that Ft is acting on point C and that point is on pitch circle diameter. So Ft is equal to torque divided by R. These are pitch circle radius. Remember this formula. So in which the torque is T is the torque, T denoted here the torque transmitted by helical gear in Newton mm. And where R is the pitch circle radius of driving helical gear in mm. Clear? Now come to the next force is a radial force. The radial force always acts along a radial line through the pitch point and directed towards the center. It acts along the radial line through the pitch point and directed towards the center. So for finding the Fr, I am considering triangle EDC. EDC. See triangle EDC. EDC. Here you can see here EDC. If that plane is perpendicular to your eyes and that is front face on that cube. Okay, so EDC, in this triangle EDC, this angle is phi t, pressure angle along transverse plane, and this is tangential force, and this is FR, a radial force, is nothing but the side of this triangle EDC. So ED is parallel to FR. So ED is FR. So FR and FT. By taking the relation is tan relation of this pressure angle, tan phi t. Tan phi t is equal to FR divided by FT. Okay, tan phi t is equal to FR divided by FT. So FR is equal to FT into tan phi t. Remember these formulas for solving the numericals. So FR is equal to FT into tan phi. Don't remember the formula, don't by heart the formulas. Just you understand, if you remember this figure clearly and the different triangles here, which triangle lie in which plane, also that you can find out the relation of FR, FT and FA. Okay, so tan phi t is equal to FR divided by FT. So value of radial force is equal to FT into tan phi t. Okay. Also from triangle ABC, you can find out FR. Triangle ABC, 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 okay, which is in inclined plane. ABC, you can see here FR. So parallel to FR is length AB, AB, and that is the resultant force AC. AC is the resultant force here, and that is FN, pressure angle along normal plane. Okay, so what will be the relation? Sin phi n is equal to FR divided by F, hypotenuse. Opposite side divided by hypotenuse. So what is FR? FR is equal to sine Fn into F. So FR is equal to sine Fn into F. Okay. So from this formula also, or from this formula, either this formula or this formula, you can find out value of radial force. Now come to a third force which is acting on at point C, and that is the resultant of F, the axial force FA, and that axial force is undesirable component of resultant force F. In the application, that FA is undesirable. Why? Because that FA force tries to slide the helical gear on the shaft on which it is mounted. It will tend to slide on the shaft. Okay, so that force is undesirable component of resultant force act. It acts in axial direction. So for finding the axial force, we have to consider the triangle BDC. The triangle BDC. BDC, which is on bottom surface of this cube. BDC, this triangle BDC is, you can see from top view, BDC. Okay, so BDC is shown here, BDC, and BCD is making angle alpha. BCD is making helix angle alpha. here BDC. Okay, and in BDC you can find out, you can see two forces. One is a tangential force Ft and axial force Fa. And to that axial force Fa, the line BD is also showing axial force Fa. BD is again Fa. So tan of alpha, if you take the relation of tan of alpha is equal to Fa upon Ft. Okay, Fa upon Ft. Tan alpha is equal to Fa upon Ft. So axial force will become here Ft tan alpha. Ft tan alpha. Don't by heart these formulas, just remember the figure carefully. So Fa is equal to axial force is equal to tangential force into tan alpha. Okay. So resultant force F, as you learn in first year engineering mechanics, the resultant force acting on the helical gear is determined by under root of three mutual perpendicular forces, square of three mutual perpendicular forces. So F resultant force will become here under root Ft square plus Fr square plus Fa square. These three forces are mutually perpendicular to each other. So resultant force will become here under root Ft square plus Fr square plus Fa square. Okay, so these three forces acting on gear tooth profile, and you can solve the numericals by using these formulas. Okay, so end of this session, the student can understand the different forces acting on helical gear and solve the numericals on force analysis. The deviation may come in the examination, and you have to write the deviation. You have to write these all formulas with help of drawing the neat sketch. Okay, thank you.